In this video, we are going to discuss about how to design and implement basic combination circuits or sequential circuits in Vivado 2017.1. So first you have to go to the software, then you have to click create project. In that, go to next, and you have to select a project name as this, and project location. You can type whatever you want. Then you click next, and then the project type should be RTL project. Then you click next, create file, go to create file. The file type should be verilog. The program language we are going to use is verilog, and I am going to do a full added project. Okay, so without space you have to type the file name. Okay, then click and then click the next. Okay, so if you see the target language must be verilog and the simulator language is mixed. Okay, so click next. Since it is optional, you go for the next step. You have to select boards. In that, you have to select basys 3. Okay. Then now, you click next. Finish.
And that baby thread, you see it again.
Then it is asking about the module name as full adder, and you can type input. Okay, input as A. Then I can give another input as B. External C. Since I have 3 inputs. Okay. So next I can change it as out. Out is sum. Next, next output is carry. Okay. So you can see in the design source, it has mentioned this one is nothing but a top module. So you click this one. Okay. So here you will get the header file. That is module. Module name is full adder. And inside this one, we have 3 inputs, A, B, C, and output, sum and carry. So, you have to write a program. So, I'm going to assign sum is equal to A XOR B XOR C. Okay. Then assign carry. Carry is equal to
It's a component and they need to be back and completed. First in the day in
AB. Okay, A and B. Okay, plus this is a plus symbol. Okay, this one is a plus symbol, and BC, BC, and this one is C A. Okay, so you save this project. Then click run synthesis. So it's running here. It's also showing in this top right corner. then you click OK. Soft click. So it is running the implementation. So here the implementation is completed. Okay. After completing the synthesis is successfully completed, you have to go for the writing the test bench. So it can be done by pressing the plus button and go to add or create simulation source, then click create file, then you give the file name as full adder test, click OK, then finish, then click OK, then yes. So if you click yes, in the simulation source, if you see, you have two symbols. One is full adder and full adder test. You click that full adder test. So if you scroll down, you will get you have to start writing the full adder test program. So test bench is nothing but writing the inputs and outputs. So first you have to start with the input, right? Since if you see the full adder program, you have inputs and followed by outputs, right? So you have to follow that order. So first register, instead of input, you have to write register, REG, REGA, REGB, REGC. Then for output, you have to write wire. So wire, it is sum, right? So wire sum, then wire carry. Good. So after that, you have to map this one, right? So you have to write the full adder program module name. So what is a full adder program module name? That is full adder, right? Full adder. So you give the name, that is UUT, then open basis and close basis, give semicolon. So inside the open basis and close basis, you have to map this A with that main program. So you have to write dot A of A, comma, dot B of B, okay, comma, dot C dots of C, comma, dot sum of sum, comma, dot carry of sum, of carry. So after that, you have to give initial followed by begin followed by end. Okay, so in the between this begin and end, you have to write the inputs, right? You have to give the values of input. Also for A, I am giving 0, B is equal to 0, followed by C is equal to 0, semicolon. So you have to give, say I want to give the next inputs, right? So for that one, I'm giving hash 10. So after 10 nanosecond, I'm giving the another set of inputs. So I'm just copying this one and giving now C value as 1. Okay. So again, I'm copying this one. I'm giving B value as 1. Next, I'm copying the same thing and I'm giving B and C as 1. Next, I'm replacing A by 1 and now A and C by 1. Next, A and B by 1. So last step, giving all the values as 1. So after that, I'm giving hash finish, sorry, dollar finish, saving the file, and run the simulation. So if you see, you have seen the symbol like this. So click run simulation, then run behavioral simulation. So this window it will open. So you can see in maximize this one, and if you see for 3 values of 0, someone is carry, it is given. So after 10 nanoseconds you can see C value is 1, so the sum is 1, and B value is 1, so sum is 1 and carry is 0. So for 1 1, sum is 0 and carry is 1. So this is how you have to check the simulation. So after that, you click run installation. So now we are going to create, so I'm going to create a constraint file. Okay, so for that one, you should have a basis port with you, and you should know what are the inputs, are its inputs and outputs. Okay, since it is a combination circuit, we don't require a flip clock. Okay, so if you want clock means you have to choose W5. Okay, so once if we are getting the implementation and successful, you have to click OK. Okay, so in that you have to go to IO port. Okay, so this is a basis. In that you have to click LVCMOS 33. Okay, and say how to, by checking the basis port. Okay, so the inputs are R2. Okay, this is R2, and the next one is T1. The next one is U1, and the LED is your output, that is L1, and P1. Okay, so you save this so you will get this window will open. So you give a full adder constraint. Okay, full adder constraint file. Okay, so you click OK. So now the constraint file is open. Okay, if you check this, the full adder XTC represent constraint file as so once it's completed, you click generate bit stream. So now it is running. Okay, see this 3.3 represent 3.3 volt. So usually this program it get converted into bit streams. So this is called as a netlist. Okay. So the final output it's in terms of bits. So the file name here, the stored here is in terms of bits. Completed. Then after that you click open hardware manager. So you have to connect the FPGA board to the CPU. Okay. Then you click open target, auto connect. Then click program devices. So you can see the full adder which we have programmed using verilog stored in terms of bits. Then you program the FPGA. So I have programmed the FPGA. So this will look like this. Okay. So you can see it is showing ABC. So if I so this black button is in 0. Okay. If it is down means it is 0. If I move up means it is 1. So whenever if it is 0 0 0, the sum and the carry is 0. If I make C as 1, you will get sum as 1. If I bring 1 1 means carry will be 1. So if I make triple 1 means sum and carry will be 1 1.